All right, so cube root functions, those would be the inverse of something to the third power. So if you remember from back in chapter 6, this would be a function that would have an x-intercept at 0 with a multiplicity of 3, right? Remember multiplicities of 3? It's a crossover, but it looks more like a roller coaster. So it's kind of like a half parabola here, and then another half a parabola here. So that's what to the third power looks like. So if I want to graph its inverse, the cube root of x, it would have to be a reflection over that line y is equal to x, which is actually kind of difficult to do, right? So I will just help you out. You see how on the original it's like pointing up and pointing down? Okay. For this one, the origin is still going to be the origin, the center point, but instead of it pointing up and pointing down, it points right and left. So on the right side, it's like above the x-axis, and when it points left, it's under the x-axis. Now, for some reason, students have a hard time graphing this one. So I'm going to give you some advice. You guys just graphed square root functions, and you did great with it. I walked around the room. You guys knew how to do this. It's just a half a parabola, right? So start off by graphing a square root function, half of a parabola. To complete the cube root function, you graph the other half of the parabola facing the other way. That's all there is to it. So it's like you graph a square root function going to the right, and then you graph the other part of it going to the left. That is our parent function, we're going to call it, and the only point you really need to graph is that center point. And so when we translate or move this function around, left, right, up, and down, that's the only point we need to move. We're going to keep the shape the same. Okay, we're not going to expand, we're not going to have an A value of 15 or something and see what that does to it. That'll be for another day. Here, this is going to be the shape we're going to stay with. But the rules stay the same that we've just done. So if I say, what is the graph, cube root of x plus 1, and that's under the radical sign, and then I have minus 4, tell me in words how that parent function moves. Where that middle dot is now located. No. What is this what does the plus 1 do to it as it's underneath the moves to the left 1 spot, so we would say left 1, and then down 4. Right? All right, so let's try that. Here was our original. We're going to move left 1, down 4. Here's our new guy. And then that's the important spot. Now it's just, okay, square root function, one way, do the other way, and you're done. Nothing real magical here. Just getting practice of graphing this. It's like a half a parabola one way, the other half a parabola the other way. Domain and range should be easy. All real numbers. You can use the double line for the R. That stands for all real numbers. For set notation, you would write from negative infinity, comma, to positive infinity. Same thing for range. All real numbers, negative infinity, positive infinity. Yes, ma'am.
I feel like, okay, so like that point right there on that third graph right there that you made. So that's basically like the origin. So like when we're doing like the -4 and the plus whatever, that's basically moving just the origin.
Yep.
Okay.
Yep, we're moving that center point for our
For the
cube root graph.
crossover thing? Okay.
What if we had this one? F of x is equal to the opposite of the cube root of x. What does this guy do here? Remember from the last one? What did we call that? This one doesn't open one way or another, but I wrote it up there. We said it was a reflection. You reflect over the x-axis. Okay? So, listen, if the original went over the x-axis to the right, the reflection of it would be under. So it would look like this. So anytime that you've got the negative out front, that just means it's a reflection over the x-axis. These are the same rules we've used for all the graphing we've done. How we move things left and right, up and down. The whole idea of reflecting over the x-axis. We used to say opens up and opens down because we had v's and parabolas. But that really was a reflection. Domain and range for cube roots will always be what? All real numbers. Yep. The domain and range for square root functions, those are the ones that you need to really watch, right? Those will be different. And you have a worksheet for today. I'm going to hand that out to you. And that is one of those required assignments that does need to be turned in.